All right, welcome back again. This is called the video on balancing chemical equations. You probably have done this in middle school, but it's been a while, so we're going to go ahead and refresh and see what we can, because balancing a chemical equation is the foundation to stoichiometry. So what is a chemical equation? Let's start there. A chemical equation describes a chemical change. Okay, parts of an equation, we went over this in class. You have the reactants. Make sure you're doing Cornell style notes, guys, okay? You have the products. And one thing we talked about is if the arrow points to the products, okay? And your reactants are what are involved in the original chemical change. The arrow stands for to produce, and the product is what is made, okay? So reactants and products. Reactants, the chemicals that you start with before the reaction, they're usually written on the left side of the equation. The products are the new chemicals formed in the reaction, and they're on the right side of the equation. Okay, so subscripts, why are they important? Remember, they show how many atoms of an element are in a molecule. And if I have H2O, I have 2 hydrogens and 1 oxygen. Okay. Coefficients. This is something new. We did talk about this in both of these in class. This is the one right here. I should change my color. But coefficients show how many molecules there are present. Okay, I don't know what I just did. We're going to pause. Sorry about that. I was trying to figure out what was going on with my pen. Coefficients show how many molecules there are in a particular atom. So if I have 3 H2Os, then I have 3 water molecules. What does that mean? That means now I have to take 3 times 2, and now I have 6 hydrogens and 3 oxygens that are present in 3 water molecules. Okay, so here's the chemical reaction. You have, or this is the foundation, the chemical reaction, law of conservation of mass. Sorry. In a chemical reaction, matter is neither created nor destroyed. So that means that what you start with, you have to end with. Okay. So the number of and type of atoms going into the reaction must come out. So what goes in must come out, the same number. Okay, if an equation obeys the law of conservation of mass, it is balanced. Okay, it's balanced. So let's take a look at this unbalanced equation and see what I mean. Okay, so here is CH4. Okay, you got your carbon and you have 4 hydrogens. You also have an O2, 2 oxygens. On the product side, if you have carbon dioxide, which is made when you have methane and oxygen combining, they combust and they make carbon dioxide and water. Well, if you look at this, I have 4 greens over here, but I only have 2 over here. I have 2 reds, I have 3 reds, and I have 1 carbon, 1 carbon. Well, this means this is not balanced. What I started with is not what came out. So this is an unbalanced equation. So in order to balance this equation, we're going to have to double our oxygen molecules, and we're going to have to double our water molecules. Now we have 4 greens, 4 greens. Okay, we have 4 reds, 4 reds, 1 gray, 1 gray. Everything is balanced. Okay. All right, some rules of the game. I want you to copy these down for sure. Okay, so matter cannot be created or destroyed. Subscripts, very important, this one right here. This is what a lot of people try to change. Subscripts cannot be added, removed, or changed. They cannot be added, removed, or changed. You can only change coefficients. Okay, this is number 2 big one here. Coefficients can only go in front of the chemical, never in the middle. Okay, try balancing big formulas first. Save the free elements for last. So if it's all by itself, like O2, leave it for last. If you have sodium phosphate and you have a polyatomic ion in there, do those first. Okay, that's usually what happens. Also, if the same exact polyatomic ion appears on both sides, it's usually treated as one unit, and I'll show you what that looks like in the next video. All right, there's no one particular way to balance. So if you like doing it one way, and I do it another, do whatever you need to do, okay? Um, so, all right. So we'll stop this video here, take some notes, summarize what is going on, and bring it to class. Have a good night.